Hello everybody, this is Admika and you're watching Mickey STEM. Today's video is going to be about energy forms and changes. And as you can see, we've got a really nice platform here and we're going to be discussing a lot about energy and how energy can be transformed. Now, first things first, of course, energy cannot be created or destroyed, so we're just going to be looking about how it can be changed and the different forms of energy. So I'm going to go ahead full screen. Okay, so as we can see, we have a great template, and I'm using, as you can see in the bottom right corner, PhET simulations. These are simulations, so these are like interactive tools. And you can go online and type PhET simulations, and there's a lot of different tools and resources that you can use, such as physics, chemistry, math, and biology, earth science, whatever. You can use for any tools or materials that you need, or just for learning purposes. So let's get started. So first, we can clearly see that there's a lot going on, and I see this little pipeline with this kind of horn type thing. I'm not sure what it's called, and I see this big wheel here, which I'm assuming if you turn, something is going to be happening through this pipeline or wire, and something is going to be happening to this water cup here. So I'm just going to go ahead and click this energy symbols. What this is going to display what's happening to those energy molecules or those energy formations. We'll be seeing what exactly is happening to those. First, we can see that there's mechanical energy, which is typically happening in mechanical systems, like maybe in a bike. When you are pedaling, there is mechanical energy due to the bike's rotation and the chain as well. And then we have electrical energy. Mechanical energy is the gray one, so if you see this gray cube with the E in it, it means there's mechanical energy. We see electrical energy, which is this blue. Electrical energy obviously comes in electricity. So if you are maybe charging your laptop, there's obviously electrical energy in that charger. And almost any type of wire has electrical energy, or it won't do the work it's supposed to do. And there's again our red, which is thermal energy. Thermal is basically heat. Heat, can be produced in a lot of different ways, and that's going to be a red. So the sun produces thermal energy because it is giving off heat. Then for our yellow, we have light. Again, I can give you maybe the example of a light bulb. The light bulb shines, so it gives off light energy. And there's chemical energy. Chemical energy can be made in a lot of different processes, like photosynthesis. Plants go through a lot of chemical energy. Or one very good example is, for example, me eating some food. In my digestion, I'm creating chemical energy that's transforming, and that is sourced into power and energy for my body. That is also fuel. So there's a lot of different types of energy, and we're going to be discussing how those can be produced and how those can be transformed in this simulation. So just to give an idea of how this whole system works, you might be seeing these little boxes here. On this box, on this bottom left corner, we saw 4 squares with different images in them. This is where our going to be input is where we're going to be putting the energy in. For example, in this pipeline, when I'm tuning this, I see that it's dropping water and mechanical energy due to the pipeline. And I see that there's the sun, which I can already see that it's giving off a lot of the yellow cubes, which we know the yellow cubes are light energy. And here I can see that there's none clouds, and if there's a lot of clouds, you see that some of the energy is getting bounced off, so it's fully not fully coming out. And this exactly explains why on sunny days we feel more hot and on cloudy days we might feel a little more chilly, because the sun's light doesn't the sun's light doesn't come all the way to us, and that also means that there's no thermal energy either. So I'm going to go ahead and take this out. And I see there's a tea kettle, I guess, and we have this little box, this little bin here, where we can produce heat. And we see that there is thermal energy as well as mechanical energy due to this coming out of a tea kettle. And I also go down and there's no heat now, so there's no energy coming out of it. And then there's this bicycle here where we see a girl. As we can see inside her body, there's a lot of chemical energy because maybe she has fed herself. And she's starting to pedal a little bit, and now she's starting to pedal a lot. And we'll go through one of these one at a time. Again, here on this side, let me go back to the water pipe. We can go on to this side. We see that there is this wheel here, and we also have a solar panel here. And on our output side, we have a water tub, we have a light bulb, a different kind of light bulb, and a fan. Let's start with the water, we'll start with the wheel, and we'll go ahead and start with the water pipeline. So I'm going to go ahead and keep tooting this horn or pumping water out of it. And what do I see? Well, I see there's obviously water, but why is the wheel turning? Well, I see that there is mechanical energy that is coming out of the water pipeline. Water doesn't have like energy because it is just water. So, and I see that it's pushing, the water is obviously pushing on the sides of the handles on the wheel. And what is that wheel exactly doing? Well, since it's connected to a wire, that mechanical energy that's getting transferred to this wheel, as you can see following these, is turning into electrical energy. All this electrical energy is now going into the water, in which we see that is turning into thermal energy. We cannot have electrical energy inside water, so it turns into thermal energy, especially if the water is hot, which we see the thermometer that it is pretty hot. And we also see steam rising because some of the energy is getting released. That's why if we put our hand over a boiling pot of water, we can feel that there's heat because the water also releases some of that thermal energy. Okay, so we've got a good idea of how this thing works. Let's move on to the sun. So without even saying anything, I can already see that the sun is releasing so much light energy. It's a bright and sunny day. So we can see there's a lot of light energy that's coming off because the sun is a very big ball of gas, so there's probably going to be a lot of light. And just looking at this, I see that there's a lot of energy that's getting released. But why isn't exactly this wheel moving? Well, I obviously see that none of the energy that's going through the wheel is also not going through the wire. Why? Because this light energy is very free going and it's spreading out everywhere. The sun is also very far away, so it's not producing enough energy to keep the wheel moving. Because as we can see, the light energy is spreading around everywhere, and there's not enough in one section near the wheel to keep it moving. But let's say I include a lot of clouds. Well, now I see there's not a lot of light energy anymore. There is, but not that much. Well, that's also why we say that sometimes when it's cloudy, it's more dark, because the sun is releasing the light energy, but it's also, I guess you can say so-called, bouncing off the clouds, so we don't get as much as light anymore. or it's blocking the energy now because the energy can't get past the clouds. Of course, in some areas it will. For example, in this place there is no clouds. That's why you're getting more light energy over there. Let's say, and that's why we feel pretty dark. So this is a very good explanation of why we feel it's dark when there's clouds and why we feel very bright when there's no clouds. If I take it in the middle, I took one cloud out, and we still see that there's actually more energy that's getting released because now we have very few clouds. So we clearly see that the sun is not enough energy to push this wheel and boil the water. So let's go ahead and check out the next one, which is our little steamer or tea kettle. Not sure exactly what you call it. But obviously this tea kettle isn't doing anything because there's no energy that's in it right now. So what's going to create that energy? Well, there's only one option, which is heat. I increase the heat, and obviously, as you can see from the fire, it's turning into its thermal heat, and now it's transforming into mechanical energy because it's coming out of a tea kettle. And you see this big bubble here. That basically means a lot of steam because there's a lot of heat, so there's going to be more steam. That's pretty obvious. And now we see that the wheel is moving. Why? Because all that energy is directed to the handles of those wheels, and the energy is pushing it. And let's once again see that the mechanical energy is going through these wires. It's coming down and it's turning into electrical energy. And now I see that it is boiling the water because it's turning into thermal energy. Now, we should be informed that this is not being created, it's not being destroyed, it's just changing. Energy can change, it can transform into different types of forms of energy, but they just don't disappear and then reappear as something else. They just change. So that's a very important part that we need to understand. So we clearly see there's a lot of steam rising, and if I just reduce the heat a little bit, we don't see that there's a lot of energy coming from the heat, and we see that it's not a lot of energy is coming out right now. Let's say I don't put any heat at all, so there's not even going to be any energy, and we can see the steam bubble is slowly going down, and now that the wheel is also coming down to a sudden stop. Well, let's check out the most important example I feel is the bicycle example. Another thing to note is that slowly the thermal energy is also very few, and now that there is no heat to keep it, heated up, the thermal energy is also releasing into the air, and the temperature is also dropping. So let me check this. The bicycle. So we see this happy girl who is ready to bike around, and since this is not the same wheel, we see that there's a rope that is tied around her wheel and also tied around this much larger wheel. And we can obviously guess what's going to happen. She starts pedaling, this wheel is going to move, the rope is going to move, and so is this wheel. And that's a very good function, of course, and it seems to be working very well. Let's go ahead and make that girl pedal just a little bit. As you can see that it's slowly pedaling and the wheel is slowly moving. Let me increase it a little bit. Say she is biking a little more faster right now. What's going on? What do we see? Well, inside her body, say she had a very good healthy breakfast or healthy lunch. We can see that there's a lot of chemical energy in her, which is transformed from eating, and now she's getting extremely tired, so let's go ahead and feed her again, feeding her another healthy snack. Let's see that now, due to the way that she's pedaling and it's going through the bike system, is obviously now mechanical energy. And it's also sometimes, let's feed her again, Let me reduce this just a bit so she doesn't get so hungry again. It's also releasing a little bit of heat energy due to the power that she's pedaling. Now, after this mechanical energy, we see the same thing again, that it's turning into electrical energy and it's going to boil the water with thermal energy. Now, an important thing to know is this girl's bicycle here. It's very important why we eat food. Now let's see, she's pedaling very, very fast. See, the more harder she's pedaling, the more she's using the chemical energy. The more the energy let's slow it down now. The more food that she's eating, the more energy that she's getting, she's putting it into her legs, her pedaling. And that energy is getting used by chemical energy and is now turning into mechanical energy. So that's why it's also very important to eat powerful food that gives you energy, so that you guys feel more active about things and you have more chemical energy in yourself, so you guys can make something like this too. You guys can push a wheel as well. Now we're gonna have to feed her again. Right? So perfect. Now, what I do want to change is I want to change this to a solar panel. So let's go back to our water pipeline and see, instead of the water, I'm going to change it to a light bulb. And that's an interesting light bulb, yeah. So I'm going to toot my horn, and I'm seeing that the mechanical energy is coming out, but nothing is really happening. Well, I mean, it's a solar panel. Do you really think mechanical energy is going to help a solar panel to come out? No, I really don't think so. But if you really think about it, what is a solar panel based on? It's based on receiving light energy, or possibly thermal energy, but I think it's mostly light energy. So while water does not produce any light energy, as we can clearly see from the demonstration, well, I'm assuming the sun produces light energy. Let's go ahead and check if it possibly, well, yeah, it is bouncing into the solar panel, and some of that is getting converted to electrical energy, and we can see that it is now turning into thermal energy. It is heating the bulb up, which will produce it to produce light, and now we see the light bulb is glowing. So not all of that energy is directed to the solar panel, which is very obvious, but a lot of it is, so it is able to power the light bulb, which is very, very important. Now let's say I'll put just about this many clouds. Let me change the light bulb here. And now I can see that this is a different type of light bulb. Actually, this gets converted into thermal energy, but I don't think this gets converted into thermal energy. It just uses direct electrical energy. Some light bulbs are like that. And now due to the clouds, we see that there's less energy that is coming to the solar panel, which is converting less electrical energy. As we can obviously see that once this electrical energy goes, it doesn't convert to thermal. It just uses that electricity to now just power the light bulb. But the thing is, the electricity is not constantly flowing, so if it's not flowing, it just doesn't stay lighted up. It just stays dull. So let's say I have less clouds, and now how much can I possibly get in now? Yeah, so now we can see that it's staying more lit because we are putting more electrical energy and there's a constant flow of electricity. So that's gonna work. Let me try the tea kettle. Let's see if let me try this light bulb now. Let's see if that heat is going to do anything. Interesting. I see there's a lot of mechanical, I see there's a lot of thermal energy, but it's not affecting the solar panel. Well, it's heat. So solar panels, the way solar panels are designed is so that it only reacts to light energy. And currently, light energy, we have a very, very large source, much larger than electrical energy, which um, is what your regular light bulbs are used for. But since we want to cut that out, chemical energy, maybe it's possible, but light energy, we have a much bigger resource. So it's designed to only react to light energy. And now we see that the thermal and the mechanical are just getting released into the air. It's just plain steam. So, well, that doesn't affect the solar panel, so it doesn't affect the light bulb. And I'm assuming it's going to probably be the same thing for this as well. It's not going to power it at all because none of that energy affects the solar panel. So maybe, okay, I guess there is no thermal or mechanical energy. Let's try it over here. Well, again, I have a bunch of chemical energy to store. She's ready to go. Let me start pedaling there. I see the power is going through her legs. It's getting, well, there's a little bit of thermal energy. Well, here's the issue. After it becomes mechanical energy, where does that mechanical energy go? It doesn't have any use because it is no longer connected. The mechanical energy can't transfer into the solar panel. So there's a very big idea here. So when we see the mechanical energy in the wheel and the pedals, we see that it can't go into the solar panel because solar panels aren't designed to take in that energy. So it directly gets converted into heat energy to release heat. Now you might be thinking, well, I don't feel that heat when I'm bike riding. Well, you may feel that heat sometimes if maybe it's a more hot day and you get tired out because, your legs are tired out, you might be sweating. That's probably why. But due to that, you can see that there's not a lot of heat energy that's coming out. So we typically don't tend to feel it that much, but it's definitely there. And we are moving forward, so we're not going to feel it behind us exactly. Let's go ahead, Peter. So we only see that the only resource for solar panels to power a light bulb is only going to be the sun. And that's the only way it's going to be able to power the light bulb. So let's go back to our wheel. And now I'm going to try to power a fan. Now please do know that this is the side view of a fan, just to give you an idea of whether it's spinning or not. I'm not sure why it's side view, but you can see the wires more clearly. Now I know the sun is not going to affect the wheel because light energy doesn't do anything to actually push. So I'm going to go ahead and use my tea kettle here. I'm going to put it up to full heat. We have a mechanical from thermal to mechanical. And we see it's going through the wheel now, it's electrical. And now we see it's mechanical back again. And now I see the fan is indeed moving. So obviously the mechanical energy is getting released because, well, it's a fan. So, well, the fan is moving due to the electricity that's getting powered from that wheel and is releasing mechanical energy because it's a moving, it's a mechanical object. So we can clearly see how that works. We see the transformation. Do note that it is it's a change in our energy and it can power. So, maybe you can do something yourself. You can go ahead and heat up a strong tea kettle and a wheel that you can move and wire it to a fan. And maybe you guys can try this experiment at your own home. Let me go ahead and try with this water pump. We see that it is still moving. And you can see there's a lot of mechanical and electrical. There's a lot of mechanical energy going on here. Just during this transformation are we seeing electrical energy because we're using a lot of mechanical systems. This water pipe is a mechanical system. This entire wheel is a mechanical system, and so is this fan. So that's very important to note here. because we're using mechanical engineer. Sorry, not engineer, energy. So, well, that was really cool. We can try to test out, well, we obviously know the sun isn't going to work. We can try to test out the bike once more and see if she's able to power that fan up. Let me go ahead and just get the fan back on. So, she has a lot of chemical energy stored, and I'm going to make her pedal pretty hard. Electrical, there's a lot of electrical. Then there's our electrical. We see our mechanical is getting released out. There's our mechanical, then there's the electrical, and then there's the mechanical once again. So we see the same process repeating as long as that girl keeps putting in the same chemical energy. It will change and it will be transformed to power up different devices as well. So this has been great, guys, and thank you guys so much for watching. I really hope you guys really understood how things work here with energy, and it's been so much fun using this simulation. I find this simulation very useful because I can see how things generally work in everyday life. So you kind of understand how fan is kind of powered up, where maybe it's coming from. As you can see in your wires, there's a lot of electrical energy, and then the fan is releasing mechanical energy. I'm going to go ahead and put that pump there. And it's been really cool, guys. You guys can go ahead and go to the PHET simulations. They have tons of simulations, and you guys get to learn so much on a variety of topics, and it's really, really fun. I hope to do this again. Thank you guys so much for watching. I'll see you later.